Hey, so we're going to talk a lot about standard form of linear functions tonight. We're going to take a look at a couple of word problems where standard form is going to be more helpful to us than what we've been kind of focusing on in class. As you recall, in class we've been focusing a lot on y equals mx plus b, where m was representing kind of our rate of change, and b was representing our y-intercept. And specifically, in these cases, we had two variables, our x and our y, and those represented an independent and a dependent variable. So we were able to plug some value in for x and get some value out for y. We also talked a little bit about kind of the situation where maybe there isn't an independent or a dependent variable. What happens when we run into these questions, we run into these situations where there are two unknown quantities, there are two variables, but neither one of them appear to be causing the other one to do something. Neither one appears to be an independent or a dependent variable. And that's kind of the situation we're going to look at this evening. Okay, so let's take a look at some standard form stuff. So the basketball team wants to hold a fundraiser selling cookies and cupcakes. They plan to sell cookies for $1 each and cupcakes for $2 each. Write an equation to show how many of each they will need to sell in order to raise a total of $250. So there's a couple things that we don't know in this question. And the very first thing that we're going to try to do when we set up a word problem is we're going to go looking for our variables. We're going to define our variables. Well, there's two things that I seem to not know. I don't know how many cookies they're going to sell. We're looking to sell some cookies, and I don't know how many cupcakes they're going to sell. And I want to know how many of each. So I need to set up a couple variables. I'm going to set them up. There's no particular reason why I'm choosing to do x represents cookies and y represents cupcakes. There's no real reason why I'm choosing x and y in that way. One of them is not independent versus dependent. The number of cookies doesn't really have a huge impact on how many cupcakes I sell, and vice versa. Cupcakes is not going to influence cookies. However, if we're trying to raise some amount of money, like $250, the more cookies I sell, the less cupcakes I will have to sell. And the more cupcakes I sell, the less cookies I will have to sell. So they are kind of related to each other, the amount of cookies and cupcakes we're selling, but one is not necessarily independent versus dependent. So I'm going to take this now. I'm going to take these variables, x representing the amount of cookies I sell and y representing the amount of cupcakes, and I'm going to write an equation. And that equation is going to need to total to $250. Whatever I sell has to end up equaling $250. Well, I'm going to make $1 for every cookie, and I can write that as 1 times x. And I'm going to make $2 for every cupcake, and I can write that as 2 times y. So I can say that $1 for every cookie plus $2 for every cupcake has to equal $250. This equation is written in standard form. Standard form, as a reminder, is this form where the x and the y variable, since neither one appears to be independent or dependent, they end up on the same side of our equation. 1x plus 2y equals 250. Cool. So let's see what else we need to do with this. Well, we need to be able to graph that equation. So let's think about what that equation was again. It's 1x plus 2y equals 250. And I need to graph that. Well, how can I graph standard form? We really have a couple of different options here. The easiest option for us is going to be to find the x-intercept and the y-intercept. Now, do you remember what the x and the y stood for in this particular question? Right, so the x stood for cookies, and the y stood for cupcakes. So before I get too far into this situation, I'm going to go ahead and put on my x-axis that it represents cookies, and my y-axis is going to represent cupcakes. Good little reminder for me in a little while. And in order to find the x-intercept, I am going to cover up the y term. So if I think about that going away, I end up with something that says 1x equals 250. And if I divide both sides by 1, x turns out to be 250. So my x-intercept is going to be 250. And now let's go back over to our original equation, which said 1x plus 2y equals 250. And if I want to find the y-intercept, I'm going to cover up the x. I'm going to make the x go away, and it's going to say 2y equals 250, which means that y has to be 125. So I have an x-intercept and I have a y-intercept. Now to graph an x and a y-intercept, the x-intercept is going to be on the x-axis. So I'm going to go to my cookie axis, and we can set up some kind of scale here. Maybe we'll want to count this out by, let's see how many boxes we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 15 boxes on here. So maybe we will count by, let's count by 20s. That means that every 2 boxes is going to be a 40, 80, 120, 160, 200, 240, 280, etc. And we said that our x-intercept was happening at 250, so a little bit past 240, like that. Our y-intercept is happening at 125. We'll go ahead and keep the same scale here. 40, 80, 120, 160, 200. I don't need to go even further than that because the y-intercept was 125, which is just a little bit above right there. And then all I need to do is connect my line from here to here, and I have completed my graph. All right? So finally, that last thing we need to do, and I'm going to go over to this next page here, I actually included a graph from Desmos. So I kind of graphed this online and just to kind of show you what it would look like in Desmos. And we still do have that y-intercept of 125, and we still do have that x-intercept of 250. The couple things that are missing on here was a reminder of what our axes stood for. Our x-axis was cookies, and our y-axis was cupcakes. And now we want to interpret this graph in terms of the question. So what does the x-intercept represent? What does that point right there represent? Well, that point represents that in order to raise $250, I could sell 250 cookies. So one way to raise $250 would be to sell all cookies, 250 of them. And what does the y-intercept represent? What does that point represent? Well, that point represents that if I don't sell any cookies, that I could instead sell 125 cupcakes and reach my $250. So I've got a couple of options here. When I start looking at my x versus my y, I could sell 250 cookies and no cupcakes, and I would be able to get up to that much money, $250. Or I could sell no cookies and 125 cupcakes, and I would still get my $250. Finally, what does the line represent? So that's kind of my favorite question on here. What does this line represent? You see this red line is connecting a lot of other points. There's a point going on right here, and there's a point going on right here, and there's a point going on right here, and there's one here, and there's one here, and there's all these different points, because that's all a line is, right? A line is just a collection of an infinite number of points. What do these other points represent? Well, let's take a look at it. Let's look at this point right here. And we look at kind of what that x and that y is. It's telling me that one option is I could sell 150 cookies with 50 cupcakes. Well, does that make sense? 150 cookies would be $150, and 50 cupcakes, since they were $2 each, would be $100 more. That's going to also sell $250. So what does this red line represent? It represents every possible combination of cookies and cupcakes that would add up to $250. Cool. So that is it for this first question. The next question that we're going to do, and this is the last question because we don't have a lot of time here, we're going to look at one more example like this, and I'm going to kind of let you get ahead of me. I'm going to do a lot more kind of pausing and let you think about the question before we move on, all right? So here we go. Howard D. McMillan Middle School would like to have a winter dance show to raise money for the arts programs. They will sell adult tickets at a cost of $6 and student tickets at a cost of $4. Write an equation to show how many of each kind of ticket they will need to sell in order to raise $300. So let's think about this for a moment. I've got to define variables. I've got to define my x variable, and let's do that part together so that we're all on the same page. Let's say that x is going to represent adult tickets and y is going to represent children tickets. If x represents adult tickets and y represents children tickets, write an equation right now that would be able to describe how much money how many tickets they'll have to sell to raise $300. Go for it. Cool. So you should have come up with something along the lines of $6 for every X ticket, which is the adult tickets, plus $4 for every Y ticket, the kid tickets, have to add up to $300. Cool. Let's now try to use that equation a little bit. So we had 6x plus 4y equals 300. Find the x and y intercepts and use them to sketch a graph that models the situation. So take a moment right now. Try to find the x-intercept and the y-intercept, and in your notebook, try to sketch yourself a little graph. It doesn't have to be perfect, but do your best to sketch a graph so that we can use that graph to interpret the situation. Go for it. Cool. So we should have been able to find the x-intercept by covering up the y. And that would have given me 6x equals 300. And when I divide by 6, x turns out to be 50. And we could have done 4y equals 300. If we want to find the y-intercept, we would have just covered up the 6x. And we divide that by 4, and y turns out to be 75. And then on that graph that you drew, we should have labeled the x and y-axis. The x-axis represented adult tickets. Our y-axis represented our children tickets or student tickets. We need to do some kind of scale on here. I'm going to go ahead and count by 5s on my x-axis. So we're going to go 5, 10, 15, 20, 25, 30, etc. I'll do the same thing on my y-axis. We don't have to have the same scale on the x and y-axis, but when those numbers are close enough together that it makes sense to have the same scale, it's never a bad idea. All right, so the x-axis was sitting at 50. Our x-intercept was sitting at 50 adult tickets. Our y-intercept was sitting at 75 children tickets. And if I then go ahead and connect those lines, connect those points, I will get my line, my equation, my function here. Cool. So if you got that, you're on a really good path. Now the last thing we need to do is we need to take that information and we need to be able to interpret it. So I'm going to ask you to think about, looking at your graph in your notebook, what does the x-intercept mean? What does the y-intercept mean? And then what does the entire graph show us? Cool. So the x-intercept in this particular equation, in this particular situation, the x-intercept represented what the number of adult tickets was that we could sell. Let's go back and just show you what the number of adult tickets was that we could sell if no kids came. So if only adults went to the show, we would need 50 adult tickets to reach the amount of money that we were trying to raise. And the y-intercept is going to show what's the number of children tickets we will need to sell if no adults come to the show, and that would have been 75 children tickets. And the line, that line just represents every other possible combination. For example, right here's a pretty good point, And that point says that we could sell 40 adult tickets. Well, 40 adult tickets, each adult ticket was costing us $6. So 40 times 6 would be $240. That's 40 adult tickets. And then if I kind of come across to my y-axis, that's 15 children tickets, and the 15 children tickets each cost $4. 15 times 4 is 60. And if I add my adult and my student tickets, I reach my $300 I was trying to raise. Every other point on that graph represents some combination of adult and children tickets that we could use, that we could sell in order to raise our $300. So I want you to kind of think back through this, take a look at your notes. I know this was a video that was a little bit on the longer side, but I wanted you to really get a feel for how we could use standard form. And if you have any questions, write them down right now in your notebook. That way when you come back to class tomorrow, first thing you can do is raise your hand and say, I didn't understand when you blank. Fill in the blank, all right? Have a good night, and I'll see you guys tomorrow. Bye.